Okay, good morning, everyone. As usual, how did the homework go? Do you have any questions about it? Okay. And please have your camera on. Very few of you had their camera on.
I had a question about H.
Please go ahead. Okay. H. So we have the integral from 0 to 1 of cosine 3x minus 3. Okay. All right. So definitely we don't have cosine x. We have cosine and we have something in here. Okay. So how are we supposed to do that? So it's a definite integral. We have to compute the antiderivative. So, okay, ideas. Please put your camera on.
Wouldn't we first make the u to 3x minus 3?
Right. First, we have to make the u to be 3x minus 3. So we have an inside function. And the derivative of it is 3. So we know that we don't have an issue with that. So let's do it. So we're going to put u to be 3x minus 3. We compute the derivative. The derivative of 3x minus 3 is a 3 dx. Okay. Now, this is a definite integral. So we can either change the limit immediately or we can wait to the end. So I'm going to change the limit immediately. Okay. What do I mean? If x takes the value 0, my new variable will take the value minus 3. Means I plug in 0 for minus 3. If x is 1, so that's really what I'm doing my substitution. I'm substituting the upper and the lower limit. If x is 1, my new limit is 3 minus 3, which is equal to 0. Now doing that, my new integral will become the integral. I'm going to change everything. Instead of 0 is what u takes at 0. The value of u at 0 is minus 3. Instead of 1, the value that you take at 1, which is equal to 0. And now the regular substitution inside. Cosine 3x minus 3, that will become cosine of u. The dx, I have to pull it from here. So I need to divide both by 3 to be able to pull the dx. So a third du. And now it's basically a simple integral in u. 1 over 3 is a constant integral from minus 3 to 0 of the cosine u du. So that's an integral in u that you have to evaluate. So this will give me a third. Antiderivative of cosine is the sine. And now my between minus 3 and 0. Since I change my limits, I don't have to go back to x anymore. So now I forget totally about x because I changed my limit. So finally, this is going to be equal to 1/3 sine of 0 minus the sine of minus 3. And the sine of 0 is equal to 0. And this would give me minus a third the sine of minus 3. And a reminder that whenever we're working with sine and cosine in calculus, the unit is radian. It's never grade. It's never degree. Okay. All right, let's look at the other ones you guys struggling with. So that's take care of which one this one. This is H. So let's see E. What is E about? Okay, it's all the same basically ideas. So we look at E. Okay, look at E here. integral from. So E is the integral from -1 to 0 and 1 over 1 minus 4x dx. Okay. Right, this one I will ask one of you and see how they did it, just out of curiosity. Natalia, how did you do that?
So I put 1 minus 4x as u.
Is this the natural thing to do, right? We have this denominator we have to deal with. So naturally, we're going to put u to be 1 minus 4x. Did you change the limit at the beginning or you didn't?
No, I didn't.
You didn't. Very well. So I'm going to follow her. She did not change the limit, which is okay with me. So I'm going to follow this approach this time. No change of the limit. Okay. So the derivative of 1 minus 4x, that's minus 4 dx. So she didn't change the limit, means that first we compute the antiderivative and then we apply the fundamental theorem. So this is equal to, watch, I'm not worrying about limits now because I'm just going after the antiderivative. It's equal to 1 over u for this piece. The dx from this one, I divide by 1 over 4 dx. So from this one, I will get minus over 4 du. So now we're done. Minus 1 over 4 integral of 1 over u du. It means 1 over 4 ln of u. It means I did not put constant because I know at the end my goal is a definite integral. Ln of 1 minus 4x. Okay, as you realize at this stage, the only thing I'm doing is finding the antiderivative. That's what I did because I did not change the limit. Now I go back to my original integral. So now the integral for minus 1 to 0 of this is equal to minus 1 over 4 ln evaluated between minus 1 and 0. Now, this minus 4 could be factored out. So I will have minus 1 over 4 times the ln, just to make the math easier, between minus 1 and 0. Okay. And at the end, I will have minus 1 over 4 times ln at the upper limit, which give me a 1, minus ln at the lower limit. If x is minus 1, I plug it in here. I will have 1 minus 4 times minus 1, it's a minus 4. So I will have 1 plus 4, means ln of 5. I didn't need the absolute value. This would leave me with, this is 0. And minus minus, it's a plus, ln of 5. Okay, and we definitely stop there. All right. Okay, I have the D, and then I think we'll be fine. So we'll look at part D. Please ask questions if you didn't get the same answer or anything like that. So let's see what D is about. D, okay. D. It's the integral from 1/2 to the square root of 3 over 2 of 6 over the square root of 1 minus t squared dt. Okay. All right, question, ideas. Who did that problem?
I can do it.
Go for it.
I factored out the 6 because then 1 over the square root of 1 minus t squared would just be the inverse sine of t.
Exactly. Factor it out, you mean she took it after. Okay, that's what you mean, factor it out. And then this would leave me with this. All right. Watch, that's not a substitution problem by any stretch of the imagination. Because if I put u to be 1 minus t squared, The derivative is 2t, which is, and there is no t inside. So substitution is totally, out. So how we're going to do that, as your classmate told you, is just the formula. So here, the only reason I gave this to remind you that the derivative of arc sine of t is 1 over the square root of 1 minus t squared. And the whole problem is basically to remember this formula. So this will gonna give me 6 times arc sine t evaluated between those two values. Okay, and that's the reason why, because the derivative of arc sine is this. So finally, I'm done. I evaluate at the upper limit minus at the lower limit. Okay, and finally, it's gonna give me equal to 6 times. What's the arc sine of the square root of 3 over 2? Meaning, what is the angle whose sine is square root of 3 over 2? Anybody remember? What is the angle? When you compute its sine, you get square root of 3 over 2. Anyone remember? Pi over 3. No, it's the pi over 3. Minus. Arc sine a half means what's the angle? When you find its sine, you get a half. The angle whose sine is a half is pi over 6. Okay, and the rest we just basically evaluate. So pi over 6, that would give me 2 pi minus, let's give me pi over 6. And the answer is pi. Okay. All right, so I guess this will do. I think I did all of them. Okay, so one of your classmates tell me questions about number 1 and 2 on the review. What are your questions, Eli? Because I thought
well, I was looking at review 2.
yes.
I was kind of confused about the way the questions were asked. It was
Which one?
Well, to start, like with just 1A, like the very first question.
This one?
Yeah. So when it says write the sum clearly, is it asking for the sum in summation notation?
No, if it is only 6 subdivision, I don't care about sigma notation.
Okay.
I want it here. When I'm asking you about to write as a limit of Riemann sum, I want the sigma notation here.
Okay.
Okay.
So I just solved 1A. Okay.
All right, so here you just have to subdivide between 0 and 3. You subdivide into 6 pieces. So you find the delta x.
And then it doesn't matter. Obviously, it didn't tell us whether to use a
Yes,
right,
if I didn't
left, or
tell you, I
midpoint.
don't care. If I didn't tell you, I don't really care, because actually it doesn't really matter eventually, because when the number of subdivision is very, very large, they both take almost the same value. So if I didn't tell you, you choose. If I tell you, you have to choose to do exactly what I tell you.
Okay.
Okay.
And then for C,
okay, for C.
I did the problem. I may or may not have gotten it right. I found this website that did a similar problem, and it found a way to solve for x sub I as well as delta x sub I.
Mm-hmm.
Obviously, it didn't solve for numerical value, but
No. Yeah, no. The only thing I want from here is actually I want something fairly simple. The idea is that you're taking this interval now and you divide it into n equal pieces. With
okay.
me, right? So, and we label the endpoint. So this we label it x0, x1, x2, etc. Are you with me? So a typical one, so this like I call it xi, and the one next to it I can call it xi plus 1, right? Am I all right? Are you following me?
Yeah, no, yeah, I got you.
Yeah, so now this is the sum of what? My function is x cubed. So basically you are adding the xi cube, so it's x0, let me take the right sum, x1 cube plus x2 cube plus x3 plus xi, etc. And each one of them, because this is the output, you multiply it by delta x, which is to really reflect the idea. I'm taking the value of the function here times the delta x, because this is the function. Okay, and then the value of the function here times delta x, and so, sorry, it's nonsense. The value of the function here times delta x, the value of the function here times delta x, the value here. That's really what I am doing. And I'm adding this from 1 to n because I'm taking x1 cube, and then we're taking the limit of that as n tends to infinity. That's the sum I want you to write.
Okay.
Okay, nothing deeper than that. I can find formula for xi, but it really doesn't, I don't really care about that. This is our dxi.
Okay.
Okay, any other questions? Very good.
Um,
Go ahead.
well, yeah, I'm just looking to see if I had any other questions that I'm forgetting about. What about, okay, so then what would the summation, what would the, for 2c then?
Okay, it's sigma.
Yeah, the sigma notation.
And what's the
Okay,
function?
it'd still go from,
If I take the right sum from 1 to n,
okay,
and then we basically, that's what we are doing. We're taking the value of the function at xi, we're multiplying it by the delta x. That's what we're doing. So what's the value of the function? It's xi squared minus 3xi. This represents the value of the function at xi.
okay, so with the sigma notation, as far as we're concerned, for the most
Yes.
part, it's gonna go from I equals 1.
To n, yes.
Okay.
If you
Okay.
do it to left sum, it means you go from 0 to n minus 1 of the same thing.
Okay,
That's the
and then
only
would
difference.
it, and then would it be x sub I minus 1? Or am
Minus
I,
3xi, it depends on the function. 3xi square minus 3xi.
okay, and that's what it would look like?
Yeah. Mhm. This represents what? This represents the value of the function at xi. That's what to
Mhm.
represent. Okay, because in the picture, that's exactly what we are doing. We're taking this function, which looked like that. And what are we doing here? We're splitting and take the value of the function, whether in the right one, the value of the function here times the delta x. That's the picture. The value of the function, that's what we are, times the delta x, times the delta x, times the delta x, times the delta x. That's exactly what I am doing.
Yeah, that makes sense.
Yeah, that's verbatim. But sigma notation, otherwise I will be sitting here writing f of x0 times delta x plus. That's why we use the sigma notation, just to make it a little bit simpler.
Yeah,
Very good. So,
all right, thank you.
sure. Okay, that's my last question, number J for Natalia. Sorry, I put the paper away. I thought I'm done. And what is this? J. Okay, we do that, and that will be hopefully the end. 1 over t times 1 plus ln of t, the whole thing squared dt. All right. Ideas. Who was able to do it, and how did you do it? What do you
I have
see?
a question.
I'm listening.
What would be the u? Would it be the 1 plus ln of t, or the entire denominator t times 1 plus ln of t?
What do you think? What do you guys think? What's going to be the u?
I
1
used
plus
1
ln
plus
t.
ln of t.
Yeah, 1 plus ln of t. Why? You just answer me. Why? What do you
Because
see?
when you take the antiderivative of the ln, it would be 1 over t, and there's already 1 over
Right.
t.
You mean the derivative, not the
Derivative, I mean, yeah.
Absolutely correct. 1 plus ln of t is a wonderful choice because when we take the derivative, 1 over t. 1 over t is gone. Basically, the problem is solved. Okay, so let's do that. So as you guys realize, we have to watch. I always tell my students, you have to stare, just stare. What's really going on? So we're going to do exactly what you guys said. I'm going to put u to be 1 plus ln of t. My du is 1 over t dt. And I see it. I see this 1 over t dt. It's right there staring at me. Now I'm going to change limit. Change limit. When my t takes the value 1, my u will be 1 plus ln of 1. ln of 1 is 0. This is going to give me a 1. When my t is equal to e, my u is going to be 1 plus ln of e. Now, if ln of e is equal to 1, this will give me a 2. And now I'm going to transform my whole integral into an integral in u, and I'm changing my limit, so I will be safe. So my 1 become a 1. My e become a 2. That's the equality. And now, 1 over, the 1 over t dt, this combination, this is my du. The 1 plus lt, it's going to become the u squared. So this integral on t, this definite integral on t is equal to this definite integral in u. I changed my limit. I'm safe. So now I forget about t. I evaluate that. So that's the integral from 1 to 2 of u to the minus 2 du. Now, antiderivative of u to the minus 2 is 1 over minus 2 plus 1, u to the minus 2 plus 1, evaluated between 1 and 2. So this is going to give me minus 1 over u between 1 and 2. Now, this is a constant. Actually, I can really take it out. So between 1 and 2, you don't have to, but make math easier. And that's give me minus. At the upper limit is a half. At the lower limit is 1. A half minus 1, that's minus a half. Let's give me a half. End of the problem.
Where do you get the 1 over u squared again?
Oh, here. What's your u?
My u's 1 plus the natural log of t.
What do I have here? 1 plus
1
ln of
plus
t to which
Yeah.
power?
Oh, it's squared. Okay.
That's the problem.
Can
Okay.
you go over why you changed the limit again?
Why? Because when you do substitution, we can do it 2 ways. If I don't change the limit of the substitution, I have to go back to t again. If I change the limit, I don't have to go to the original variable anymore. That's really how substitution works when I have definite integral. So if I didn't change the limit,